Hello and welcome back to the lecture of time series econometrics. So we are talking about the properties of AR and MA series of higher order, and in this lecture we are particularly going to focus on the covariance of MA2 series and MA series of higher order. Now in the previous lecture we have seen the variance of MA2 series, that is sigma square plus 1 plus theta 1 square plus theta 2 square. Now we'll deduce the covariance for MA2 series here. So let me write down covariance for MA2 series. Covariance for MA2 series. Now to do that, what we will first get is we will have, let's say we will take lag 1. Okay, MA2 series with lag 1. Let me just write down lag 1. Lag equal to 1. Okay, so which means my covariance term would look like cov yt minus 1. Now what I'm going to do here is I'm going to actually expand this yt and yt minus 1 in terms of the as MA series, right? So yt is basically epsilon, let me write epsilon t plus some theta 1 epsilon t minus 1 plus theta 2 epsilon t minus 2. Okay, and then my yt minus 1 is going to be epsilon t minus 1 plus theta 1 epsilon t minus 2 plus theta 2 epsilon t minus 3, right? Great. So now if we substitute the yt and yt minus 1 values here, it will look like equal to, so let me write it from here, covariance of yt is epsilon t plus theta 1 epsilon t minus 1 plus theta 2 epsilon t minus 2, comma, I have my epsilon t minus 1 plus theta 1 epsilon t minus 2 plus theta 2 epsilon t minus, that is 3, right? Epsilon t minus 3. Epsilon t minus 3. Right. Now, when I multiply this term, so let me have more space for. So when I multiply this term, terms within covariance, so what will happen is I will have the first term et minus 1, which is basically going to be 0. Then et minus 2, that's going to be 0, and et minus 3 is going to be 0. Here, epsilon t minus 1, epsilon t minus 1, so that term will remain. So that means I can write theta 1 epsilon t minus 1 square, right? And then if I multiply with other terms, epsilon t minus 1 and epsilon t minus 2 and epsilon t minus 1, epsilon t minus 3, they are going to cancel out because of the IID property, right? Now I can add the theta 2 epsilon t minus 2. The first term will cancel out. The second term, well, that will remain theta 1 theta 2 epsilon t minus 2 square, right? And the last term will, of course, will cancel. So t minus 2, t minus 3, they will cancel out. So now these values, epsilon t minus 1, epsilon t minus 2, epsilon t minus 1 square, epsilon t minus 2 square, and their expectation, they are basically going to give us what? The variance of the error term, which is nothing but the sigma square. So I can write theta 1 sigma square plus theta 1 theta 2 sigma square. So which is sigma square into theta 1 plus theta 1 theta 2, right? So that's basically the covariance term for lag equal to 1. Okay, so that's very important. The lag, it is this value that I got is for lag 1. So you can also replace 1 or minus 1. So basically they're the same thing. It depends on in which direction you are doing the shifting, but the value remains the same, right? Now if I put lag equal to 0, what I'll get is basically the variance. So the variance that we have already got. So that is for, say I can write this value is for, this is for lag equal to 0. I can write lag equal to 0, okay? Just to sort of bring all the results in the same place. So this is for lag equal to 0, right? And the last one, this is for, I got it for lag equal to 1 or minus 1, for lag equal to 1 or minus 1, right? Now then I will now see if I increase the lag, what will happen to my covariance term, okay? I'm going to use here, I'm going to use the space here. So if I increase the lag, say I use cov, here I will use, so I'll take a lag 2. So basically I will take cov yt and yt minus 2. Exactly following the same manner, we are going to substitute the values of yt and yt minus 2 here, right? So I'm going to write, I'm not writing it separately in the same equation, I'm writing yt is my epsilon t plus theta 1 epsilon t minus 1 and theta 2 epsilon t minus 2, right? And here yt minus 2 is going to be epsilon t minus 2 plus theta 1 epsilon t minus 3 plus theta 2 epsilon t minus 4, right? So these are the values we got, right? Now if I multiply them, again I will see, I can write cov of, so et minus 2 cancels out. In fact, all the terms with et will cancel out. Et minus 1, again they will cancel out. Only thing that will remain is theta 2 et minus 2. So basically I have theta 2 et minus 2 square, right? Now I know this, I can take the theta 2 out, and this value, this cov of et minus 2 square is nothing but the variance of et minus 2 square, and since this is an IID error term, so I'm going to get a sigma square, right? So this is basically for my lag equal to 2. So I write for lag equal to 2, okay? So this is another result, all right? For lag equal to 2. Now I will do one more of this, and where I'll increase lag equal to the 3 or anything actually that is beyond 2. Now let's make a guess what will happen, okay? So I should use a different color because it is looking too congested now. So here I'll use a green color maybe. So let me write down cov yt and say yt minus 3, okay? So which will mean the second term here, whatever we got, it is actually going to start from 3, right? And the first term is actually going to end at t minus 2. And the second term is going to start from t minus 3, t minus 4, t minus 5. Now then there will be no two et which are same, right? If I multiply the two terms, any of this, from the terms in two equations, so then all of them are going to give us, if I take an expectation, all of them are going to give us 0 value. So basically, in this case, what you're going to see is, let me again come back to the white color, is going to be equal to 0 for lag greater than 2. So this is another result, okay? So we got this 4 results. So, the covariance for lag equal to 0, lag equal to 1, lag equal to 2, and lag equal to more than 2, okay? Now, so that's about the covariance. Now, if I want to get the correlation coefficient, it's very simple. You just need to, divide this. So the correlation coefficient, or rho, I can get rho, like in general, I write, say rho k is equal to gamma k by gamma 0, right? So gamma 0 is nothing but the variance, right? So the variance and the covariance. So variance and covariance with lag k. With lag k. So we have our gamma 0 value, right? Which is nothing but this variance term here. And so you take all the covariance terms for different lags, and if you divide that with gamma 0, so you get the covariance. So that's basically how you get the variance and covariance for MA2 series.